nice. It shows go. So now I can go. And OK. So the ERC and Content-Addressable Logic Modules, that's a quite technical talk for today, where we set up a standard that enables some different way of working for the developers, deployers, and builders, auditors as well. So it might have some interesting side effects on several segments of the industry, I would say. For those who are not patient enough, here's the QR code to go to the ERC. So you can quickly go through it and then raise the questions based on the content. We're 3 people actually working on this ERC. Now it's in the review state, so it's close to be finalized. I was working with Nick Much. Nick Much is the author of the Diamond proxy pattern, so the upgradable, quite like robust, strong upgradable pattern. And Bill is also quite a known persona in the Ethereum and Ethereum magician space. So why some new standard to deploy and develop things? The reason is that currently we have fragmented logic, or I would say redeployed logic for many, many times across even, let's say, one EVM chain or across the whole EVM space, meaning like in the multi-chain manner. What does it mean? It means that most of the people that want to build, I don't know, for example, a fungible token like ERC-20, they go to the OpenZeppelin website, or they use the Hardhat or Foundry to use the framework of the OpenZeppelin and just start creating the contracts, and then they deploy those contracts again, again, again. So basically the same code with the same logic, just with the different token ticker is basically redeployed many, many times on chain. So that's the duplication of the logic that actually somehow populates the chain quite a lot, and it's like broadening the whole space. So what we are bringing here is that since many of those tokens need to be upgradable or whether using the proxy pattern, that we are proposing some what we call a column architecture. And that is that we would have a contracts that would be reusable. Basically, their identity is your address of the contract. And you do not need to redeploy them on the same chain. You basically reuse them, if they have the same functionality or capability like what you need to have. If you go a little bit deep down, why it happens, this, let's say, identity of the deployed contracts, is that the typical EVM deployment, where you have the create or create-to opcodes or mechanisms, they relies on several aspects on how to derive the resulting address of the deployed smart contract code. For instance, here is mentioned create-to, where you have the initial code, so basically your runtime bytecode plus whatever there is in the constructor, and then also the salt, and in many cases it's also depending on who actually deploys that. So those are all those like parameters or variables that impact the outgoing address or outcoming address of the deployed code, which actually results in the fact that it's being deployed on different chains towards the different addresses, and that creates the headaches for the DevOps or for operations. So what we are proposing is that runtime bytecode itself is basically the identity, meaning that we avoid the Initcode. We would apply some constants, which are like generally known constants, and the only variable would be the runtime bytecode. So based on that, any logic that we need to deploy on the EVM chain will result into the same address. Like for instance, when you have IPFS and you have the content deployed there, it's always existing on the same, let's say URL, right? On the same hash ID. So this is very similar logic, but applied towards the smart contracts. And I know, and I see some friends from Solana space. Solana also has it a little bit in a quite similar space, but what we are proposing is that it will be highly decentralized and highly like permissionless. So we do not propose like centralized entity, but rather that anyone can deploy and have the identity derived from the runtime bytecode. If we think about what are the impacts or how we need to work with that, it means that we have to avoid any initial like constructor code. The impact for some people, unfortunately, is that there will not be able to be any immutables because immutables are actually being done or created within the constructor, within the Initcode. And we also concluded that these columns, these logic modules, they need to avoid self-destruct, right? Because when you have the proxy architecture, the self-destruct in the logical code would actually destroy the proxy. So something that keeps the, let's say, the business information, the data, the storage about of the users. So those are the key limits that are there. And if we comply to these limits, then we have a pure cryptographic determinism of the resulting module. So what we say is that the runtime bytecode becomes the identity. How we achieve it? We bypass the Initcode, that we have some specific factory, and that actually serves as that constant for being the deployer. That factory can be, again, permissionlessly redistributed across chains, even those that are not yet existing. And that factory brings that microconstructor. So it replaces that Initcode, it replaces the constructor with a fixed, constant microconstructor. And we also fix the salt towards the 0. So the only variable, as is mentioned here, is the runtime bytecode. Where it is possible to use it, it's on the daemon facets as a way behind the daemon proxy. Also, there is a new ERC contract for the proxy design, and that's for the modular smart contract. So something similar as the daemon is, but more like generic and more aligned towards the computer science, I would say, and the generic terminology for the dispatch proxies. What it also allows is that those columns, or actually we say that those columns, it's themselves that they are stateless, right? They execute the logic for the proxy. So the business logic is there, but the state that they impact is the state of that proxy itself. And one thing that we ask the users is that they need to prevent the collision of the storage, right? Because that's one of the reasons of the hacks, that the storage collision. So that needs to be described. Yes, you either use the daemon storage or use the namespace storage, like the OpenZapLand does. It has interesting side effects, and that is that we can skip the proxy, the dispatcher that is being implemented by default by the Solidity. Meaning, if you have like the proxy over here, and there is only like one function actually being implemented by the column, then you don't need to have that secondary dispatcher there, because that proxy does the dispatching just itself, right? So that proxy can call a different columns, but if the column is highly atomic, that it executes only one capability, one function, then you don't need to deploy their additional dispatcher, which is currently being done by the Solidity. So that's a possible way to skip it. That's the right side, that is atomic logic. Or, as is current situation, you can have like a multi-method column with the internal dispatcher. It just works as well. We also discussed some metadata dilemma, because there is the impact on the verification on the indexers when you apply the source code and resulting hash into the runtime bytecode. So that's open the user to decide We have the examples in the ERC are described the examples where you have the logic-only identity, meaning there is no metadata hash. It's purely based on the functionality, right, on the runtime bytecode. So you strip the metadata, or which can be perfectly fit for very easy to decompile or very easy to understand the runtime bytecode, like for instance, the call towards the decimals. Or the full source identity as it is common right now, it has also some impact, but perfectly, in both cases, it's permanently replicable columns. It's perfectly fitting. Within the ERC, there is a discussion on under which cases it's suitable to use what. So you can look it up there. Then we also created some tooling related when you consider to deploy these logical modules. The hashcarve, it's open source tooling that actually enables that deployment onto the different chains on the same address, right? That's basically the factory deployer with some features that are related towards the verification of those columns. So here's the QR code, by the way, for that. And regarding deploying, one needs to decide whether they want to deploy those columns or whether they want to deploy something that keeps the storage, right? That keeps the state, typically that proxy. So based on that, if it's stateless logic, perfectly, the columns are the perfect things because they can be reused among the projects. I am creating some project like the stablecoin which was mentioned here, and I will need to prepare and deploy some important business logic there. And your project can basically reuse that, or part of it. So the stateless logic, the business logic itself would be deployed by the hashcarve deployer. Anyone can permissionlessly to reuse it or redeploy it onto the different chains, which will result in the same address but somewhere else. And regarding the particle storage for the business itself, that's within the proxy and that needs to be deployed in a different way, like create X, for instance. That's another deployer. So here you can see the comparison on that. The address identity, there's the key one is that it's content addressable is for the columns. Whatever the proxy, it's typically the salt addressable or actually the deployer addressable. That's the key differentiation, I would say. And the impact on the users is the very bottom line here, and it is the security model. For the comms themselves, since they can be permissionally redeployed, that's basically immune to hijack. Because one of the issues which we are solving with the national stablecoin was that when we want to deploy it on different chains, even those that are not known yet, how do we avoid the hijacking that address, where the contract will be by some bad actors party, because that's one of the unfortunate conclusions when you use or when the user uses the MetaMask and somehow it's a different address on different chains, then it's much harder to spot some phishing token, right? So with the columns, that's basically immune to hijack because that's content addressable. That's based on the content, so it always results into the same. While on the proxy itself, that requires basically the control. What it has is the impacts is as we discussed, one needs to be careful regarding the storage, so not to collide when when you see the column, and you will see soon that there will be like popping up the libraries or the pieces of the code that will be existing on the chain, but you will need to think like, is this impacting this kind of the storage or that kind of the storage? Can I have there a collision, yes or no? So this is something that needs to be basically stated and cross-checked. And that's why we also elaborated some signaling of the compatibility and impact. So we call it compatibility and impact manifest that should be there within the source code of the COM. And that describes whatever it relies on. Because just to give you the example, EVM is not only in the public blockchain, but it's also used in let's say, some institutional blockchains like the Hyperledger Besu and so on, but the compatibility is highly different, right? The forks are very different, so one needs to be sure whether those pieces of codes that are being deployed somewhere, that they can literally be reusable somewhere else because of that dependency on the capabilities of the chain itself. So that's why we said the developer's intent need to be declared there. What it also enables is that if there are already existing codes, like some tooling, like a multi-call, for instance, or some factories, or let's say governance-less registries, that they can be recarved into the like canonical identity. So we brought this function into that hash carve mechanism that say, okay, from this source code, from this source address, just redeploy it into the canonical identity, and then it can be reused among the chains. So that already exists. We also developed some cross-checking function, so that basically says, okay, just verify that this is really the column that has been deployed, and not something else. And as the consequence is it enables to build like a universal library of the logic that exists among the EVM space, I would say. Not only the mainnet, but overall space. So really trustless global library of the EVM logic and universally addressable by the hash of its bytecode. And the shift that it has is that currently when you create those contracts, you create like monolithic contracts, right? At the very best, you have like a proxy, like UPS proxy, the upgradable proxy, and then behind that you have like one logical contract. That's a common pattern. This enables further to use those either diamond, modularization or that modular dispatch proxies to have those logical modules there, and it will naturally lead towards a registry-less registry. That there will be those columns being deployed, and what we believe is that the community will just lead towards those codes that are highly reused among the projects. So basically, just imagine that you would be one project, the first project to deploy like 20 atomic contracts, and all those 20 will be already audited, right, by your project. And there will be a secondary project that says like 6 months later, and it knows that it needs to reuse like 12 of those contracts, because that's the same capability that needs to be reused, like ERC-20 transfer, for instance. So you will just create a blueprint and state, okay, I want to use that code. It's already audited. And you might also audit your project as well, but then those 12 will be audited twice. So it will naturally emerges that code that is highly reviewed, highly re-audited, and highly reused. And this is one of the consequences also here, that it will have the positive impact on the users, because currently when you have like a massive amount of the different ERC-20 or NFT codes, it's basically duplicated logic, so there is a cold access penalty. Some of you might know that if you're accessing or if you're like executing the transaction within the block, there is like hot and cold access, right? So once you have those, let's say, atomic columns that are very frequently used, like that calling the decimal, for instance, then they will be basically cached. So they will be already warm for your transaction, for your contract, for your like overall solution by someone else. So this is just the convergence of that. And basically it acts as the synergy for this EIP-7863 because there's a shared logic, right? It has the impact on the developer's experience because somehow you will change your thought from like writing the code more into like declaring the blueprints, declaring on what features I want to have, and most of the features are there already deployed on EVM chain. So that will be, it will be more like constructing, it will be more like architecting what you want than writing those codes that are already existing. Of course, you will write your specific specific functions that are extra. But there will be a huge possibility to reuse the code. What it also enables is that you do this assembly locally, and okay, And you move it towards you deploy it towards the test net. You test it on the test net, and then you will just use what we have a carbon copy. You will just basically redeploy it easily towards the production network. So that's another conclusion. The another one is the impact on the agentic experience. And it is, there are two use cases which we discuss here with the people. One is that they will become the builder's agents. So the builder's agents will know what you want, or you will discuss with them what you want, and they will actually do that architecture and blueprint declaration, what they need to assemble together that is already existing on chain. And then there will be execution agents as the another use case, and it is that agent seeks some or sees some opportunity, and just in time, in the time of that opportunity, just redeploys the already existing code that is somewhere else, might be also already audited, but it will just put it into its EVM chain that needs to be there just in time. We also created, or this is the work in progress, the command line for the carbon copying it from like source chains towards the target chains. This is the idea that there could be like a web UI for that. And in general, it improves the developer experience, the autonomous operations of the agents, and improves the node performance of the EVM itself. So that's just the impact of using this ERC-8152. And regarding the status where we are, so we have the standard in the review phase. We have the deployer that's already, it's already done. So I have a final call for the features because that impacts the address. Carbon copy CLI is work in progress. Let's discuss whether there would be a need for the web UI. We think that there should be a standard for that manifest of the compatibility. And the strong thing is the call for participation on the decentralized discovery layer for the developers and for the agents. And these are the calls. So please talk to me regarding whatever we would need or what you would need as the carving canonical logic for the deployer mechanism. That's one thing. And the other thing that is a strong topic, we need to create the discovery marketplace of those columns, but we need to do it in a different way than the Etherscan is done. Right? We don't want to create like a centralized one piece that everyone will be dependent on. We want to rather do it in the, let's say, sourcify way. It means the decentralized, permissionless way that anyone could publish the column there, and anyone else can actually discover particle and compatible column code. So thank you. I would say be calm, reuse already deployed and audited code. And yes, let's discuss and see you on the next BFI meetup.